What's up, students? So in this video I'm going to solve this problem that I have asked you. So basically you have three forces here, one force of 20 Newton, 30 Newton and 10 Newton. Now this is a good example of a problem where the forces are coplanar. That means these three forces lie on the same plane, and they are collinear, which means they all meet at the same point here. So how do you go about solving a problem like this? Now looking at the information that you have been given here the angle of inclination, which is 25 degrees, and that's 40 degrees over here. So how do you go about solving this problem? So I have solved this problem for you, and I'm going to explain how such a problem can be solved. So let me place this here. Right. So what I have done is I have resolved the three forces that I have here in vertical and horizontal components. Now bear in mind, this is very important. Any force which goes upward is positive, and correspondingly any force going downwards is negative. Any force going in the left side is negative, and any force pointing in the right side is positive. Now what we have done here is we have assigned a convention for the forces. So upward is positive, downward is negative, left ways is negative, and right ways is positive. Now that we have established the convention, I'll show you how to solve a problem like that. Let's continue on to solving the problem. Now what I have done here is I have resolved all of the three forces, that is 10, 20 and 30 Newton, into its vertical and horizontal component. So that is for A. So your force is 10 newtons. So the vertical component will be 10 sine of 40 degrees because the angle of inclination is 40, and the horizontal component will be minus 10 cos of 40. That's because again the angle of inclination is 40. Now why do you have a positive and a negative sign? That's because of our convention that I was talking about earlier. You see, anything going upwards is positive, anything going sideways in the left direction is negative. So that's our convention for the forces, and I have done the same for the other two forces, that is B and C. I've resolved them into upward and I've resolved them into horizontal and vertical components. Now when a question like this is asked for your examination, you need not do these steps. You don't have to do these. I have only written this down to explain it to you. Okay, whatever I have written in a black pen, that needs to be written down. Okay, so because steps are very important while solving problems like these. So if you get your steps right, there's a good chance your final answer will be right. So now what we need to do is we need to find the sum of all horizontal forces. Now this sign here is called summation. What it means is a sum of all the vertical forces. It was vertical earlier. So if you take a look at the figure now, all the vertical forces, so you got two forces going upwards and one force going downwards. They're all in the vertical plane. So you got AB and BV going upwards, and CV, that is the resolution of force C in the downward direction, going downwards. So I'm going to write it down in my formula here. So my AV is 10 sine 40 plus 20 sine 25 plus CV is minus 30. Now when you're solving a problem like this, like this one, you need not write all the steps. Like I said, easy way to do this is you take your force, vertical component will be force times sine of the angle of inclination. So that's it. So force times angle of inclination. B, force let me just zoom out. Okay, so that's B times sine of angle of inclination, and C over here, it goes down, it goes downwards. That is why it is going to be negative. Okay, and what I do is I just add this all up and I get my summation of vertical forces. Now I'm going to show you how it is done on the calculator. Turn it on first. Oops. Right, now always remember that your calculator has to be in the degree mode. Okay, that's a small d there. Okay, so I've got here 10 sine of 40 close bracket plus 20 sine of 25 close bracket plus, now in bracket, minus 30. Now in an equation like this, whenever you come across a negative value, okay, because that's going down, you always write it in brackets. Okay, and I have entered those terms over here in my calculator. So that's 10 sine 40 plus 20 sine 25 plus minus 30, which is my last force, CV, and I press my equal to sign and I get my force, minus 15.11. So now I'm not going to write the entire number. I just need a number significant to 2 decimal places. So 15.119. So because that's a 9 there, you round it up. So whenever you have a number over here in the third place above 5, your second place goes up by 1. So 15.11 becomes 15.12 with a negative sign, which is here. Now that we have calculated the summation of all the vertical forces, we are going to calculate the summation of all the horizontal forces. Now, if you take a look at all the horizontal forces, I have here 1, 2, and the third force over here. If you see in my diagram, that's 1, 2, and 3. Now, anything going in towards the left is negative. Hence, my AH is minus 10 cos of 40, which is my angle of inclination. BH is 20 cos of 25, angle of inclination again, and because it is going in towards the right, it is positive, and CH here is 0 because now this force over here, it is pointing downwards. So when I'm going to resolve this, the net effect is going to be that the force is always going to be pointing downwards. So that is why the horizontal component of the force is 0, because my angle is 90 and cos of 90 is 0. Let me show you. Cos 90, I'm going to calculate it, it's equal to 0. Right. So once I have written all of my forces down, I'm going to write it in my calculator. So that's minus 10 cos 40 plus 20 cos of 25 close bracket plus 0. I don't really need to write the 0, but then I'm just writing it so that there is no confusion. So once I'm happy with all of my terms, I press my equal to sign, and again I'm going to round it up only to 2 decimal places. So that's going to be 10.47 because the third place is a 5. 10.47 newtons. Right, now that we have found the summation of the vertical and the horizontal component of all the forces, we are going to concentrate on finding the angle of inclination, which is theta. Okay, theta is the angle the resultant makes with respect to the horizontal plane always. So what is the formula to find the angle theta? So the formula is tan inverse of summation of all of the vertical forces over summation of all of the horizontal forces. Now if you take a look at my formula, I've got these lines here written against the I've got these the summations written in between two lines. What these lines mean is it is called the modulus function. What it means is if you whatever number you enter in, the answer is always going to be positive. For example, so now my vertical force which I calculated is minus 15.13, and my horizontal component is 10.47. So now the modulus of a negative number is going to be positive 15.13, and the modulus of a positive number will be the same, positive. So when I enter it in my formula here, I'm going to show you how to calculate it on your calculator. So what you do is you got to use the tan inverse function, which is right here, which looks something like this. That's tan to the power minus 1, right? So you press the shift button, then tan inverse, okay, and then you enter your values. That is 15.13 divided by 10.47. Now always remember to add brackets because this two numbers are being divided inside the tan inverse function. So once I'm happy with what I have written, equal to sign, and 55.3166. Now again, I'm not going to write this whole number. I only need numbers significant to 2 decimal places. So 55.316 will be 32 because that is greater than 5. Actually, when it comes to degree measure, significant to 1 decimal place is more than enough. And because it's a 1 here, I'm going to ignore it. So my resultant is 55.3. So we have now found the summation of horizontal component and vertical component. So why did we find the summation of the horizontal component and summation of the vertical component? The reason we found it was because we want to find the resultant force. So how do we calculate the resultant force when we have the summation of horizontal and vertical forces? So for that we use a formula. So the resultant force Fr will be under root of summation of Fv squared plus summation of Fh squared. So I'm going to substitute that in my formula here, and I'm going to show you how it is done on the calculator. So you don't need to write this step. You need to write the formula for your exams, and then you can obtain the resultant force in just one step. So you got your under root sign. Let me show it to you again. So under root sign, open bracket, my first force is minus 15.12 close bracket squared plus open bracket 10.47 close bracket squared. So that's my formula written in my calculator. When I'm happy with the way I have written it, all you do is you press your magic button here and voila, that's the answer, 18.39. So that's my resultant written here, 18.39. Again, always remember just 2 decimal places, no more than that. Now I know the answer over here is positive, but I have written a negative sign here. Why? Because the resultant force is acting downwards. So you got a horizontal component and the vertical component is minus 15. So I'm going to show you why I have drawn this in fact. So my horizontal component is 10.47, and taking a look at our convention here, any force going horizontally towards the right will be positive, hence that is positive FH, and any force going downwards is negative. Oh sorry, my bad. So any force going downwards is negative, and because my vertical component I got as negative. That is why I'm going to draw an arrow and point it downwards. And whenever you resolve forces, you got your horizontal and vertical. The resultant will always be between them. That's the resultant, which is inclined at an angle of 55.3. Actually, it will not always be between, it depends on your angle theta. So since my theta is 55.3, it always opens up from the horizontal plane. So that is 55.3, that's 0, 10, 20, all the way till 55.3. So that is my resultant force. And because it is pointing in the downward direction, I have a negative sign here. So my resultant is minus 18.39, inclined at an angle of 55.3. Now, why did we go through the trouble of finding the resultant and the angle of inclination, and what exactly does it mean in the real world? So for that is these are my three forces. So that's 20, 10 and 30. And to explain to you why we just went through the trouble, I'm going to take the help of my friend Jason here. So imagine here Jason is being pulled with a force of 10 Newton in this direction, 20 Newton in that direction, 30 Newton in this direction. Now as a result of these three pulling forces, Jason is going to experience a force of 18.39 Newton in this direction at an angle of 55.3. So he will tend to move this way. That's because he's experiencing a force. Now, what is the meaning of the equilibrant force? So equilibrant force is that force which stops a system of forces from moving. Okay, so it is that force that we need to apply to a system of forces which will get these system of forces in a static state, that is stationary. And hence, because I am pulling Jason in this direction, what I need to do is apply a force in that direction so that basically it doesn't move, he stays stationary. That's because if I want to pull anything in this direction, if I want to stop it from pulling, I need to apply another force in going in that direction to stop it from moving. And hence, when I apply a force of 18.39 Newton going in that direction, Jason over here will not move anywhere. He's going to be standing stationary over there. That is the meaning of the equilibrant force. Cheers.